All right, so let's talk about games. So we started talking about games last time. We formalized them. We talked about zero-sum two-player games that were turn-taking, right? And we talked about a bunch of different strategies to solve them, like the minimax strategy or the expect-max strategy. And today we want to talk a little bit about learning in the setting of games. So what does learning mean? How do we learn those evaluation functions that we talked about? And then towards the end of the lecture, we want to talk a little bit about variations of the games we have talked about. So how about the cases where we have simultaneous games or non-zero-sum games? So that's the plan for today. So I'm going to start with a question that we're actually going to talk about it towards the end of the lecture, but it's a good motivation. So think about a setting where we have a simultaneous two-player zero-sum game. So it's a two-player zero-sum game similar to the games we talked about last time, but it is simultaneous. So you're not taking turns, you're playing at the same time. And an example of that is rock, paper, scissors. So can you still be optimal if you reveal your strategy? So let's say you're playing with someone. If you tell them what your strategy is, can you still be optimal? That's the question.
Small enough game space where they know exactly what you're going to play, you won't be successful. But if you, for a zero-sum real-time simultaneous game of a larger scale, I think you could still be successful if that approach is like superior to the other approach taken.
So it's not. So the answer was about the size of the game. So rock, paper, scissors being small versus not being small. So the question is more of a motivating. I think we'll talk about this in a lot of details towards the end of the class. It's actually not the size that matters. It's the type of strategy that you play that matters, just to give you an idea. But like the reason that we have put this, I guess, at the beginning of the lecture is intuitively, when you think about this, you might say, no, I'm not going to tell you what my strategy is, right? Because if I say I'm going to play like scissors, you'll know what to play. But this has an intuitive answer that we're going to talk about towards the end of the lecture. So just more of a motivating example. Don't think about it too hard. All right, so let's do a quick review of games. So last time we talked about having an agent and opponent playing against each other. So and we were playing for the agent, and the agent was trying to maximize their utility. So they were trying to get this utility. The example we looked at was agent is going to pick bucket A, bucket B, or bucket C, and then the opponent is going to pick a number from these buckets. They can either pick minus 50 or 50, 1 or 3, or minus 5 or 15. And then if you want to maximize your utility as an agent, then you can potentially think that your opponent is trying to minimize your utility, and you can have this minimax game kind of playing against each other. And based on that,